Hello, ladies and gentlemen. Today we're going to look at medians and altitudes of triangles. We'll start with a median. A median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. The instructions for problems 1 through 3 say, draw, label, and name all medians of each triangle. All right. Well, if we want medians, if I want to put in a median for that first triangle, triangle ABC, from vertex A, I would need to know the midpoint of the opposite side, which is segment BC. And since it said draw, I'm just going to measure that in centimeters. Okay. All right. It looks like it's 5 centimeters. All right. Half of that is 2.5. So I'm just going to go over here and measure 2.5 units from 2.5 centimeters, from each endpoint. I'm going to call that point J. All right. And now I can draw a median because I know that segment BJ is congruent to segment CJ. All right. They're both 2.5 centimeters. So then if I draw the segment from A over to J, I have a median. So segment AJ is a median. All right. So segment AJ is a median. Let's put in one from B next. I'm going to come from B to the midpoint of segment AC because that's the opposite side. Okay. Well, that one also looks like it's 5 centimeters, and 2.5 would be approximately right there. And I'm going to call that point K. Okay. And now I'm going to draw the median from B to point K. All right. Now I'm going to put in the median from C to the midpoint of the opposite side. Well, I need to find the midpoint of segment AB. Looks like it is about 3.5 centimeters long. 3.5 of 3.5 is 1.75, which would be approximately right there. All right, so let's put that point there. While we're here, turn this way, we'll go ahead and draw from C over to there. Okay, all right. And that point, we're going to call it point L. All right. And what we're going to say is that segments AJ, segment AJ, segment BK, and segment CL are medians of triangle ABC. All right. Now notice that they intersect at a point. Let's call that point X. And by the way, down below here it says the medians of a triangle are concurrent, which means they intersect at a single point, which they did. And that point of concurrency of those medians is called the centroid. So point X is the centroid. X is the centroid, all right, of triangle ABC. All right, let's go to number 2. All right, let's start from point D. If we're going to draw a median from point D, we need the midpoint of the opposite side, which is segment EF. Well, I'm going to measure segment EF. Looks like it's 4.4, half of 4.4 and 4/10, and half of 4 4/10 is 2 2/10, which would put us right about there. So that's the approximate midpoint. All right, draw the segment from there to point D. Well, I need to go back and mark the other situation over here. I didn't do that. If K is the midpoint of segment AC, then segment AK is congruent to segment CK. And if L is the midpoint of segment AB, then I need to mark segment AL congruent to segment BL. All right, and I'm going to mark those two segments congruent to each other. And I'm going to call that point, that midpoint there, point M. All right, I'm going to go from point E next. All right, so I need to measure, locate the midpoint of segment DF, the opposite side. All right, that one looks like, again, about 2.5, 5, which would be 2.5, so right in there. And let's call that point, point N, and we'll draw the median from point E over to the midpoint of segment DF. Let me mark that, and we now have another median. All right, now those medians are going to be concurrent, which means I don't even need to measure that other one over there. I could if I wanted to. I can just draw from here through that intersection, and that would go over to the midpoint. I'm going to put 1 tick mark on that one and 3 on this one so that I have different tick marks on everything. Excuse me. All right, and then I'm going to name that point O. And first one we put in was segment DM, so segment DM. Then we did segment EN, all right. And then we did segment FO, are the medians of triangle DEF. All right. And if we name this point P right here, P would be called the centroid, all right? P is the centroid of triangle DEF. All right, let's go to that obtuse triangle, triangle HIG, all right? And let's measure, all right, from the opposite side of I, which looks like about 7.2 centimeters. Half of 7.2 would be 3.6, so we'll go 3.6, which would be right in there. And that point we're going to call, excuse me, point Q. Okay, all right, and that's the longest side over there, so I'm going to put 3 tick marks on that side. All right, next let's measure IH. Looks like it's about 4.2. Half of 4.2 is 2.1. All right, so we're going to call it the midpoint R of segment IH, and if we connect that with G, we'll get a median. All right, and there's a median from vertex G. And let's mark these two segments congruent, segment R and segment HR. And you can measure locate the midpoint of segment GI or not. Those medians are concurrent, which means if you've got the intersection of 2 of them, you've got the intersection of all 3 of them. So I don't need to do that. I'm just going to draw the line over there. And that means that this segment right here would be congruent to that one. Let's call that midpoint point S. And now we can say that segment IQ, segment GR, and segment HS are the medians of triangle HIG. And if we name that point in the center there point T, then we would know that T is the centroid of triangle HIG. Okay, all right, now let's move on. By the way, the centroid theorem says the medians of a triangle intersect at a point called the centroid. That is 2/3 the distance from each vertex to the midpoint of the opposite side. So in other words, the distance from E to P is 2/3 of the distance from E to N, or that PN is 1/3 of the whole distance. So if you wanted, all right, so you can say X and 2X, and then 3X would be the length of EN, so that's what that means, okay? All right. Let's go down to the next part down here. It says to label and draw all the altitudes. Well, we need to know what an altitude is before we draw it. An altitude of a triangle is a segment from a vertex from a vertex to the line containing and it should say perpendicular to the line. To the line containing the opposite side and is perpendicular to the line containing the opposite side. The line containing the altitudes of a triangle are concurrent, excuse me. The point of concurrency of the lines containing the altitude is called the orthocenter. All right, so if we wanted to go from point A, we're going to need to be perpendicular to line BC. Well, if you want to be perpendicular with your protractor, just line up this middle 5 right here on it and slide it over till you get to A, and then you can draw the line containing the altitude or just the altitude. Let's just draw the altitude itself. Okay, all right, there's the altitude because there's a right angle right there. In order to have an altitude, you have to have a right angle. Let's call that point right there point T. So now we've got an altitude from vertex A. Let's put one in from vertex B. So I'm going to line up so that my protractor is perpendicular. Notice how I line those, that little 5 right there mark, perpendicular to the opposite side, line AC, and I slide over to where I can draw a line from point B, or segment from point B down to line AC. All right, and now that's perpendicular, and let's call that point S. All right, and that means segment BS is an altitude. Now we need one from C, so what I'm going to do next is I'm going to line up perpendicular to the opposite side, which I am right now, and I'm going to slide that up that opposite side over, and or you can just run it through that point of concurrency up there, so they all go through that same point. All right, that's another thing you could have done there, and we'll call that point U. We now know that segment AT, segment BS, and segment CU are the altitudes of triangle ABC. We also know that if we name this point in here point V, V is the orthocenter of triangle ABC. Okay, all right, let's go over to number 5. All right, if we want to be perpendicular from vertex E to line to the opposite side, there's already a segment there. That's actually that side, so you don't need one from there. If you want to be perpendicular from point D, vertex D, to line EF, there's already a right angle there as well. So those two legs of that right triangle are already what we call altitudes, okay? All right, so we need to come from point E, and we need to be perpendicular to the opposite side. So I'm going to line up the perpendicular to the opposite side, and I'm going to slide my over to point E, all right? So I'm going to slide over to point E and maintain my perpendicular, and right there is, excuse me, the third and final altitude of that triangle. Let's call that point W. There is a right angle there, or it would not be an altitude. All right, and now we can name all the altitudes. From D, we go to E, so segment DE, that's one altitude. From E, we go to S, so segment EW, and segment FE, or EF, you may say it either way, segment EF, is the, excuse me, the altitude from vertex F. So those segment DE, segment EW, and segment EF are the altitudes of triangle DEF. Okay. All right, and point E is the intersection of the lines containing those altitudes. All right. So point E is the orthocenter. So point E is the orthocenter of triangle DEF. Okay. All right. Now, let's look at an obtuse triangle, because the first one was acute, the second one was right triangle, and notice that on a right triangle, two sides, the two legs will be altitudes. That's important. Okay, and now we're going to do the altitudes for triangle HIG. All right, and let's go, excuse me, with point I first, okay? All right, so if we start with point I, we're going to be perpendicular to the line containing the opposite sides, which is over here. Now, I'm going to draw that line all the way as far as I can, because there's something special happens on an obtuse triangle. Notice that the orthocenter was inside on the acute triangle. It was actually on the triangle for the right triangle. Well, it's going to be outside of the triangle on any obtuse, by the way. All right. And I need to come from point G next. And I want to be perpendicular to line HI, the opposite side. Well, to be perpendicular, I have to come down to here. So I'm going to extend line HI over toward the right, okay? And it's okay if you go over in that other problem over there. It's not a big deal. Now, I'm going to line up with that line, perpendicular to that line, and I'm going to draw from a line all the way through. And now, this intersection, by the way, is going to be your orthocenter, okay? And let's just do this. Let's see. We're going to put in the altitudes, right? So let's call this point right here point B. Let's call this point right here point A. And there's a right angle right there, by the way. So we'll call that point A, that point right there. And we need one more altitude. All right, we're going to come from H. And by the way, you don't need to do anything. You can line H up with that altitude right there, or that orthocenter, excuse me. All right, and draw from H through there. But if you want the actual altitude, you are going to have to extend the opposite side to where it crosses that line right there. And that point right there will be, let's call that point C. There's a right angle right here, okay? And now you can say that segment AG, okay, so segment AG, segment BI, and segment CH are the altitudes of triangle HIG. All right. You can also say that point, let's name this point D down here. Point D, or D, is the orthocenter of triangle HIG. All right, let's turn the page. Okay, on the next page, they tell you about a median is a line segment that connects the vertex of a triangle to the midpoint of the opposite side. We already knew that. And the three medians of a triangle intersect at the centroid. We knew that as well. And that the centroid is 2/3 of the distance, all right, from the midpoint of the opposite side, the vertex on the median. Okay, all right. So in other words, when we're looking at this example right here, this part right here is 2/3, all right, of the whole. Okay, and if you wanted to, you could say that this little part right here is 1/3. So that's 1/3, and this is 2/3. All right. If that's X, this is 2X. That's what you got to remember. Or if this is X, that's excuse me, one half of that. Okay. All right. Well, actually, this will be, yeah, 1/2 of that. That's right. Okay. Yeah, if you take half of that, you'd get 1/3. That's correct. All right, let's move on. Down here, the exercises say, in triangle ABC, AU is 16, okay? And BU is 12. And CF is 18. Well, I don't see CF. That's the distance from here down to here is 18. Okay, all right. So if that's true, all right, I would find 2/3 of that immediately, all right? 2/3 of 18, all right? And 2/3 of 18, that would be, wait a minute, 3 goes one time here and 6 times, that'd be 12. So CU is 12. I would know that immediately. And if CF is 18, half of that is 6, okay? All right. And half of 12 is also 6, so that's 6. Half of 16 is 8. So there you've got all of your distances that you're going to need. All right, so UD, where is UD? All right, U to D, we now know that's 8. So UD is 8. All right, let's go to EU is 6. All right, next we're looking for CU. CU is 12. All right, AD, where is AD? That's the whole, so 16 plus 8, which would be 24. All right, UF is 6. And BE is the distance from here to here, which would be the 12 plus the 6, which would be equal to 18. Okay. All right, now if this is a centroid, this short part right here, if you double that, you'll get CU. And if you double 12, that's 24, because that has to be 1/3 of the whole. And 12 is 1/3 of 36, so there you go. All right, now take half of that to get JU. All right, half of 9 is 4.5, by the way. All right, and what do we know about segment EU or segment UM? Let's see. We know UK is 12, and we know, EM. EM, the whole segment, the median, the median is 21. Divide that by 3, that's 7. And that's the small part. So 7, and this is twice that, 14, okay? All right, and now I believe we're ready to answer all these questions. CU is the distance from C to U, that's 24 units long, okay? All right, MU, where is M? MU is 7 units long. CK, so that's the distance from here to there, so that's 24 plus the 12, which means that CK is 36. JU, we've already taken half of 9, that's 4.5. Okay, and EU, we've already put the number on there, is 14. All right, and JD is 4.5 plus 9, which is 13.5. Okay, all right, let's turn over to the next part of our notes. All right, and let's see what it says. All right, find the coordinates of the orthocenter. Okay, well, here's how you do that. All right, I'm not going to be expecting you to be able to do that, but if you wanted to, here's instructions on how to do that. It's not going to be required, so I'm not going to go over it. All right, if you have any questions, though, you can always give me a call, text me, or send me an email, or show up in a Google Meet, whatever you need to do. Thank you, and have a good day.